Imagine you have a large library with thousands of books. Finding a specific book without an organized system would be incredibly time-consuming. This is where indexes come in handy. In SQL Server, a non-clustered index is like having a separate card catalog for your database table. This catalog allows you to quickly locate specific rows of data without having to search through the entire table. Think of it like the index at the back of a textbook. The index lists important keywords and their corresponding page numbers. Similarly, a non-clustered index in SQL Server stores a sorted list of key values from your table, along with pointers to the actual data rows on the disk. When you query the table using these key values, SQL Server can efficiently retrieve the required data by referencing the index instead of scanning the entire table. This makes data retrieval much faster, especially for large tables with frequent lookups. Non-clustered indexes are crucial for optimizing query performance and ensuring your database applications run smoothly. Let's delve a bit deeper into the structure of a non-clustered index. Understanding this concept is crucial for optimizing database performance and ensuring efficient data retrieval. It's helpful to visualize it as a B-tree structure. This visualization aids in comprehending how data is organized and accessed within the index. A B-tree is a self-balancing tree data structure that allows for efficient searching, insertion, and deletion of data. The self-balancing nature ensures that the tree remains balanced, providing consistent performance. The non-clustered index is organized as a B-tree, with the leaf nodes containing the index column values and pointers to the corresponding data rows in the actual table. This structure is designed to optimize query performance by minimizing the number of disk accesses required to locate data. These pointers are known as row locators. Row locators play a critical role in linking the index entries to the actual data rows in the table. In a non-clustered index, the row locator is typically a pointer to the row's physical location on the disk, identified by a file ID, page number, and row number. This precise identification allows for quick access to the data. This means that the non-clustered index doesn't affect the physical order of the data in the table itself. The data remains in its original order, while the index provides a logical ordering. Instead, it provides a separate, ordered view of the indexed columns. This separation is beneficial because it allows for flexible indexing strategies without altering the underlying data structure. This separation between the index and the actual data allows for multiple non-clustered indexes to be created on a single table, each optimizing different query patterns. For instance, one index might optimize search queries, while another might optimize sorting operations. When you execute a query that involves the indexed columns, SQL Server can use the non-clustered index to quickly locate the relevant data rows. This efficiency is particularly noticeable in large databases, where query performance is critical. It traverses the B-tree structure of the index to find the matching key values, and then follows the row locators to retrieve the corresponding data from the table. This traversal process is optimized to ensure minimal latency and maximum performance, making non-clustered indexes a powerful tool in database management. Non-clustered indexes play a vital role in optimizing query performance in SQL Server. Without indexes, SQL Server would have to perform a table scan, reading every row in the table to find the data that matches the query criteria. For large tables, this can be extremely time-consuming and resource-intensive. By creating non-clustered indexes on frequently used columns, you provide SQL Server with a more efficient way to locate the required data. This is particularly beneficial for queries that involve filtering, sorting, or joining tables based on these columns. When a query uses an indexed column, SQL Server can perform an index seek instead of a table scan. This means that it only needs to read the index pages and the data pages containing the matching rows, significantly reducing the amount of data that needs to be read from disk. The result is faster query execution times, reduced I/O operations, and improved overall database performance. This translates into a better user experience for your applications and more efficient utilization of your server resources. Section 4. Creating non-clustered indexes, a step-by-step guide. Creating a non-clustered index in SQL Server is a straightforward process, but it requires careful planning and execution to ensure optimal performance. You can do it using the create index statement. Here's a step-by-step guide to help you through the process. First, identify the table and columns to index. This is crucial because the right choice of columns can significantly improve query performance. Begin by identifying the table and the columns you want to include in the index. Make sure these columns are frequently used in your queries. Choose columns frequently used in query, where, join, or order by clauses. These are the columns that will benefit the most from indexing. Next, choose an index name. This name should be descriptive enough to indicate the purpose of the index. Give your index a descriptive name that reflects its purpose. For example, if the index is on the last name and first name columns, you might name it name underscore customers underscore last name underscore first name, then use the create index statement. This is the SQL command that will create the index for you. Use the following syntax to create the non-clustered index. Create non-clustered index. Index underscore name on table underscore name, column 1, ASC desk, column 2, ASC desk row. Create non-clustered index, index underscore name on table underscore name, column 1, ASC DC, column 2, ASC disk. This syntax allows you to specify the columns and their sort order. After that, specify column order and sort direction. This is important for optimizing the performance of your queries. List the columns within the parentheses in the order you want them to be indexed. The order can affect how efficiently the index is used. You can specify ascending ASC or descending DSC order for each column. This allows you to control the sort direction for each column in the index. Execute the create index statement to create the non-clustered index. This will add the index to your database. For example, to create a non-clustered index named ein underscore customers underscore last name underscore first name on the customers table, indexing the last name and first name columns in ascending order, you would use the following statement. Create non-clustered index ein underscore customers underscore last name underscore first name on customers. Last name ASC, first name ASC, create non-clustered index underscore customers underscore last name underscore first name on customers. Last name ASC, first name ASC. This statement will create the index and improve the performance of queries that filter or sort by these columns. Section 5. Practical examples of non-clustered index usage. Let's look at some practical examples of how non-clustered indexes can be used to improve query performance in real-world scenarios. Scenario 1, e-commerce website. Imagine you have an e-commerce website with a table called orders that stores customer order information. This table might include columns such as order ID, customer ID, order date, and customer email. You frequently need to retrieve orders based on the customer's email address. This is a common requirement for customer service representatives who need to quickly access order details to assist customers. Creating a non-clustered index on the customer email column would significantly speed up these queries. This is because the index allows the database engine to quickly locate the rows that match the email address without scanning the entire table. The SQL script to create this index would look like this. Create non-clustered index 9 underscore orders underscore customer email on orders customer email. This simple addition can drastically reduce query times and improve overall system performance. Scenario 2, social media platform. Consider a social media platform with a table called posts that stores user posts. This table might include columns such as post ID, user ID, content, and created date. You want to retrieve posts based on the date and time they were created. This is particularly useful for features like news feeds or activity logs, where recent posts are displayed to users. A non-clustered index on the created date column would be beneficial. This index allows the database to quickly find posts within a specific date range, improving the performance of time-based queries. The SQL script to create this index would be create non-clustered index 9 underscore posts underscore created date on posts, created date. By implementing this index, you can ensure that your application remains responsive even as the volume of posts grows. Scenario 3, financial application. In a financial application, you might have a table called transactions that stores transaction details. This table could include columns such as transaction D, account ID, transaction date, and amount. You frequently need to retrieve transactions within a specific date range and for a particular account. This is essential for generating account statements and performing audits. A non-clustered index on the transaction date and account ID columns would optimize these queries. This multi-column index allows the database to efficiently filter transactions by both date and account, significantly speeding up these operations. The SQL script to create this index would be create non-clustered index 9 underscore transactions underscore transaction date underscore account ID on transactions, transaction date, account ID. By using non-clustered indexes in these scenarios, you can greatly enhance the performance and scalability of your database applications. These are just a few examples of how non-clustered indexes can be used to improve query performance in various scenarios. By carefully analyzing your query patterns and indexing the appropriate columns, you can achieve significant performance gains and ensure that your applications run smoothly, even under heavy load.